Why details are hard to read. Architectural details can look really complicated. At first glance, there are lines everywhere, there are different materials, and several construction layers are all shown in the same place. It is hard to know where to start. Today, we are going to break down one of these drawings, a flat roof parapet detail. Step 1. The main structure. Step 2. The vapour control layer and the waterproofing layer. Step 3. The continuous insulation layer. Step 4. The external wall and the finishing details. In simple terms, find the structure, find the waterproofing, follow the insulation, and then look at the outer skin. Every building needs a structural frame. All the other construction layers are built around it. So when you read or draw a detail, start by finding the main structure on its own. Structural elements are usually drawn with heavier lines. Different materials also have different hatch patterns. In this detail, we have a reinforced concrete slab in the middle. It connects to masonry walls above and below. This is the basic structural frame of the detail. To find it, ask one simple question. What is actually holding the building up? Once you separate the structure from the other layers, the drawing already becomes much easier to read. Now that we have found the structure, let us look at the two layers below and above the insulation. Many people see both of them as waterproofing, but they are in different positions, and they do different jobs. Below the insulation is the vapour control layer, also called the vapour barrier. It sits above the reinforced concrete slab. Its main job is to stop warm, moist indoor air from moving into the insulation and condensing in colder parts of the roof buildup. Above the insulation is the roof waterproofing membrane. You can think of it as the building's raincoat. It keeps real rainwater out. But here is the important part. The waterproofing does not simply lie flat across the roof and stop there. When it reaches the parapet, it has to turn up vertically. This is called a waterproofing upstand. In most cases, the top of the upstand should be at least 150 millimeters above the finished roof surface or drainage level. So the membrane does more than protect the flat roof surface. It also turns up around the edge, almost like the side of a tray. This helps stop water from entering. At the parapet or at material junctions, you can understand this step as setting to boundaries. The vapour control layer below stops indoor moisture from moving upward, and the waterproofing membrane above stops rainwater from moving downward. Once these two boundaries are clear, we can look at the insulation. There is one main rule here. The insulation should be as continuous as possible. Think of the insulation as a warm coat around the building. If that coat has a gap, heat can escape through it in winter. In summer, heat can move in through the same weak point. This kind of interruption can create a thermal bridge. And in this detail, the parapet is exactly where problems are most likely to occur. The external wall insulation runs upward along the side, while the roof insulation is laid horizontally, but a section of parapet masonry stands between the two. In other words, the external wall insulation and the roof insulation are interrupted by the main structure. What can we do? The drawing shows a common solution. Insulation is wrapped around the inside face and the top of the parapet. One side connects to the external wall insulation. The other side connects to the roof insulation. This creates a much more continuous thermal layer around the wall, the parapet, and the roof. It also reduces the effect of the thermal bridge. When you read insulation in a detail, do not focus on one isolated piece. Follow the whole insulation line. Where does it start? Where does it go? And what does it connect to? If you can follow that line without a major break, the thermal logic of the detail is usually clear. Now that the structure, waterproofing, and insulation are clear, we can look at the outer part of the building. The external wall in this detail is a typical cavity wall, or a double-leaf masonry wall. The inner leaf is the load-bearing masonry. The outer leaf is facing brickwork. It gives the building its external appearance and helps protect it from the weather. You may notice that the insulation fills almost all the space between the two masonry leaves. There is no clear ventilated cavity. This is called full fill cavity insulation. The outer brick leaf has its own weight, so it needs to be tied back or supported. Wall ties or other load-bearing supports connect it securely to the inner structure. I will not go further into those fixings here. Instead, let us focus on the top of the parapet. The parapet usually has a coping or metal capping on top. This coping needs a slope, because water should not sit on the top surface. But the direction of the slope is very important. In most cases, it should fall toward the roof. In other words, it should slope inward, not toward the external facade. Why? If the water drains outward, it carries dust and dirt from the coping down the facade. Over time, this can leave visible streaks and stains on the external wall. So this small change in slope can have a big effect on how clean the facade looks after a few years. Now, let us look at the whole drawing again. This was our sequence. First, find the main structure. Second, separate the vapour control layer from the waterproofing and define the waterproof boundary. Third, follow the insulation and check whether it stays continuous. Fourth, complete the external wall and the parapet finishing details. What problems have you run into when drawing construction details? Which detail should I break down in the next video? Let me know in the comments.